Okay, in lesson 7.1, we're going to talk about triangle application theorems. If you look at the learning targets, the first one says, I can prove the sum of the angles in a triangle is 180. So this is an idea that we've been using already, that the sum is 180, but we're actually going to prove it in this lesson. So that's number one. The second one is I can prove that an exterior angle in a triangle equals the sum of the two remote interior angles. That's the second one, and we're also going to prove that. So we're going to have to talk about what an exterior angle is and what the two remote interior angles are. We'll get to that. The third one we're not going to prove. So it says I can prove that the segment joining the midpoints of two sides of a triangle is parallel to the third side and its length is 1/2 of it. So I'm going to put an X there. We're not technically going to prove that. We are going to use that theorem. All right, so we're going to apply these theorems, and there's actually 3 of the theorems we're going to be applying. And so we can think of them kind of as numbered right below here. All right, sum of the angles in a triangle is 180, the exterior angle theorem, and then this third one that we're not proving is actually called the midline theorem, but we are going to be using it. All right, so we're not going to use this in if-then form, so I'm not worried about writing it as a theorem. So let's just write here the sum of the angles in a triangle is 180. So for example, if this is ABC, angle A plus angle B plus angle C is 180. All right, so we're going to use that, but we're also going to prove it. So let's jump down to the bottom and we'll do that proof first. All right, so given triangle ABC, how do we prove that those angles add up to 180? Well, you're going to see why we've waited so long to prove it, why it didn't come up sooner. So we are given triangle ABC, but you're going to see in a moment what I'm going to add to the diagram. I'm going to draw a line through A that's parallel to this base. So I'm going to draw a line through A that is parallel to BC. That's an auxiliary line that I'm adding, and we haven't added parallel lines like that, but you can see now we're going to use this parallel line idea to help us. All right, so let's actually number these angles here. Let's call this 1 and let's call this 2, and I'm going to call this angle right here A, just to make our life a little bit easier. All right, so using the parallel line, right, hopefully you see a Z. Right, if you see that Z right there, we should be able to say angle 1 is congruent to angle B. If parallel, then those are alternate interior angles that are congruent. So let me mark that. But hopefully you also see another Z. All right, if you look at that one, in the same line, couldn't I say angle 2 is congruent to angle C? And that, of course, would be by the same reason. Now, look up here at the top. What do I know about angle 1, angle A, and angle 2? Together, you should see that all of them make this full straight angle, which is 180 degrees. So I'm going to say angle 1 plus angle 2 plus angle A equals 180. And my reason for that, I'm just going to say if angles form a straight angle, then they equal 180 degrees. Okay, whoops, am I kind of off the screen here? Sorry about that. All right, now take a look at what we have above, right? 1 is the same as angle B, so couldn't I take out angle 1 and substitute in angle B? Angle 2 is the same as angle C, so I can take out 2 and substitute angle C. And now you can see we have it. Substitution. And you see I have angle A plus angle B plus angle C. They all add up to 180. So really, in order to prove that theorem that we've been using for a while, you need to have an understanding of parallel lines and alternate interiors. Okay, so yes, you have to know how to prove the theorem, and then of course we're going to continue to use it. We're going to have some more kind of in-depth problems on using the fact that the sum of the angles is 180. All right, let's jump back up to exterior angle. Let's write this down first. An exterior angle equals the sum of the two remote interior angles. All right, so let's see what that means. I'm going to ask you to draw a triangle. Then I'm going to ask you to extend one of the sides out. We could actually have extended any side out. When you extend a side, you create an angle outside the triangle. That is the exterior angle. All right, sum of the two remote interior angles. All three of these are interior angles on the triangle. Think about that word remote. Remote generally means far away. So from this exterior angle, which two are the furthest away? That would be this one right here, and this one right here would be the two remote interior angles. All right, so we're going to prove that. So let's flip the page for a moment, and then we'll come back to the midline theorem in a second. So go on up here to example 2. So we are given triangle DEF with exterior angle 1 here at F. And you can see we're trying to prove this exterior angle theorem. We're trying to prove that angle 1, this exterior angle, equals the sum of the two remote interiors, which in this case are D and E. All right, so we're going to use the theorem that we just studied. We're going to use the fact that we know the sum of the angles in a triangle is 180. So I'm going to say angle D plus angle E plus, and in this case we'll have to call it angle DFE because I've got too many there, equal 180. And I'm just going to say here sum of the angles in a triangle equals 180. We're not going to use if-then form for that one. All right, now I also know the relationship between this angle and angle 1. I can see that they are supplementary, so I can say angle 1 plus angle DFE equals 180, and I'm just going to say if angles form a straight angle, then the sum is 180. But now I see that I have two things that are equal to 180. So if both of these equal, this expression right here is 180 and this expression is 180, I can set them equal. So I can say angle D plus angle E plus angle DFE equals angle 1 plus angle DFE. That's just using a little algebra. We're going to call that substitution. I substituted this in place of this 180. But now I can see that angle DFE is on both sides. So just using a little algebra and subtracting that from both sides leads me angle D plus angle E equals angle 1. So I'm just going to say subtraction on that one. You get the idea. All right, so we just proved the exterior angle theorem. Yes, you need to be able to prove it, and of course we need to be able to apply it in problems. All right, so the third one I told you we're not going to prove, but we need to be able to use it. So go back to that front page. The third one is called the midline theorem. So I'm going to have you start by drawing a picture. So make yourselves kind of a nice big triangle here, right? And if you look above and you read in that box here, maybe I can scoot it up here, it says, prove that the segment joining the midpoints of two sides of a triangle. So put a midpoint in here, and let's note that. And put a midpoint over here, and let's note that by marking congruences. So that segment right there, according to the midline theorem, should be parallel to the third side. So this would be parallel to that third side, and its length is half the length of the third side. So for example, if this length right here is 20, the length of this piece right here would be 10. So I'm going to say here a segment connecting the midpoints of two sides of a triangle does two things. One, it is parallel to the third side, and two, it is half the length of the third side. So it's parallel to the third side, and it's half the length of the third side. And we're just going to apply that in some problems. I'm not going to ask you to prove that. All right, so let's get to some of the examples. So you can cross this one out. I'm not going to ask you. That would have been proving the midline theorem. It's a little involved. So we're going to spend our time more on the applications. All right, so here's one with the sum of the angles of a triangle is 180. I ask you to find x, y, and z. So you should see 3 triangles in this picture. I want you to first focus in on the yellow one. All right, if I focus in on the yellow one, I know that 55 plus 80 plus y should equal 180. Right? If I solve that, I get y equal to 45. So I'm going to mark that in my diagram. Similarly, I want you to look now at this pink one. That's the next one, or we could have done the pink one first too. The pink one has 100, 60, and x. So I could say 100 plus 60 plus x equals 180, and if I solve for that, I get x equal to 20. So let's mark that in the diagram. All right. Now that you have found x and y, and only after you found x and y, can you focus in on this triangle right here? So now if you look at the green one, right, the green one, I can now say 20 plus 45 plus angle z has to equal 180. And if I go ahead and solve that, I get z to be 115. So the idea is I'm using the left triangle to get y, the right triangle to get x, and then after I find those two, I can use this little interior triangle here to get z. All right. Okay, let's look at the next page. I'm going to do a few more of these examples for you. Some of these are pretty straightforward. So here it says the measures of 3 angles of a triangle are in the ratio of 3 to 4 to 5. So if you want to draw a triangle, we know we can label them 3x, 4x, and 5x. Find the measure of the largest angle. Well, I know the sum is 180, so I can add them up to be 180. So that's 12x is 180 and x is 15. It says find the largest, which would be the 5x. So I would do 5 times 15, and my answer would be 75. That's pretty straightforward. This is probably the toughest one, so put a star here. You're going to see these come up in the homework too, so you're going to want to come back and look at this. I've labeled this diagram for you. They don't always do that in the homework. So it says, if one of the angles of a triangle is 80, find the measure of the angle formed by the bisectors of the other 2 angles. So here's a bisector, and here's a bisector, and so I've already labeled the diagram. If this is a bisector, those 2 angles would be the same, and if this is a bisector, these 2 angles would be the same. All right, so to do this, we're going to use 2 strategies. First, I'm going to look at the big triangle, and I'm going to write an equation. I know that 80 plus this whole angle, which would be 2x, plus this whole angle, which would be 2y, should equal 180. If I clean that up, I have 2x plus 2y equals 100. Clean it up some more. If I divide by 2, I get x plus y is 50. But now I know I have 2 variables, so I need another equation. So now I'm going to ask you to look at the little triangle, right? And in the little triangle, I would have this x plus this y, plus this angle E. All those 3 should add up to 180. Now look what you have above. I have x plus y is 50. Can't I use that to substitute in right here? So x plus y is 50 plus angle E is 180, which means angle E is 130. So I can't tell you specifically what x and y are going to be, but because I use this sum in the next equation, I'm set. So again, to refresh, I used the big triangle first. The sum of the angles of the triangle is 180. And then I used the little triangle. And then I kind of comboed those 2 ideas. Using this expression, I could replace that with 50 to solve. All right, you'll get some more practice on those. Example 7, last one here. This angle is 150 degrees. It says angle D is twice that of E. So if I call this one X, I'd have to call that one 2X. It says find the measure of each angle of the triangle. All right, well, this is an exterior angle, and it equals the sum of the two remotes. So 150 should equal X plus 2X. So 150 is 3X. So X is 50. So now if I use that in my triangles, this would be 50. 2 times 50 would be 100, right? And this angle, well, these are supplementary, so this angle should be 30. So those would be my answers. Okay? And that's going to be it. We're not going to do that last example, so we're done.